फिर से स्टार्ट करना Good morning, respected member of the Viva-Voce panel, senior faculties, colleagues, and research scholars. We are gathered today in PG Department of Mathematics, Patna University, to celebrate the Ph.D. journey of Mr. Sharvan Kumar and evaluate his dissertation titled Study on Reduction, Multiplicity, and Algebra, supervised under the guidance of Dr. Priti Singh, Assistant Professor and Head, Department of Mathematics, Patna Science College, Patna University. Now I would like to invite Dr. Amarnath to present a bouquet to Professor R.N. Pandey, sir. Next, Dr. Namrata Kumari to present a bouquet to Professor B.G. Prasad, sir. Next, Dr. Abhishek to present a bouquet to Professor Ellen Raj. Dr. Purushottam to present a bouquet to Professor P. Raj. So Purushottam sir present a bouquet to Professor S.B. Raj. And Dr. Priti to present a bouquet to Mr. P.K. Chaudhary. Sir. Now I would like to invite Dr. S.B. Rai sir, Head Department of Mathematics, Patna University, to introduce the esteemed member of the evaluation panel and brief us about the significance of research area of Mr. Sharvan Kumar.
रिकॉर्डिंग इसको बंद कर दें, इसको ऑफ कर दें. Good morning, respected faculty members, Dr. B.G. sir, R.N. Pandey sir, P.K. Chaudhary, Amit Kumar, Satendra ji, and others, senior and junior faculty of Mathematics Department and other departments, research scholars and students. It is my privilege and pleasure to welcome all of you in the significant academic occasion on the Viva-Voce of Mr. Sharvan Kumar, under the guidance of Priti Singh, Assistant Professor and Head, Patna Science College, Patna University. The Viva-Voce is not just a formal requirement. It is a celebration of scholarship, award, curiosity, and pursuit of knowledge. Sharvan Kumar has diligently worked on the topic related to ridge algebra. Under the guidance of Priti Singh, contributing to the field of ridge algebra through the topics titled A Study on Reduction, Multiplicity and Ridge Algebra. To have with us online the esteemed external senior most professor of BHU, Professor Shyam Lal, Senior Department of Mathematics, Institute of Science, whose presence brings both academic rigor and valuable insights to this process. On behalf of the department and myself, I welcome Professor Shyam Lal. On the behalf of department and myself, I extend my best wishes to Sharvan Kumar, research scholar, for a success and prosperity. This milestone be the beginning of many more contributions to your field. Thank you. Okay.
Now we will begin with Mr. Sharvan's presentation, followed by the panel examination. Please maintain a respectful and constructive environment. We wish all the best to Mr. Sharvan. Now please begin your presentation.
Thank you, ma'am. Good morning, sir.
And good morning to all of the attendees and respected sir. Good morning, everyone. I Good morning, everyone. I Sharvan Kumar, research scholar. Uh, my title of thesis is Study on Reduction, Multiplicity, and Ridge Algebra. Before proceed to the presentation, I would like to introduce all the chapters of the thesis. Chapter 1 is Introduction, and Chapter 2 is Preliminaries, and Chapter 3 is Proposal of Reduction of Module, and Chapter 4 is Multiplicity of Module in Ridge Algebra, and Chapter 5 is Coefficient of Hilbert's Polynomial of Sally Module, and the last chapter is Conclusion and some research problem, future work. Chapter 1 we present general introduction with some historical background, and in Chapter 2 we cover some essential preliminaries definitions definition which in subsequent chapter to prove the theorem. And in Chapter 3 we define the product of some module of a multiplication module, and also introduce the multiplication submodule. In Chapter 4 we investigate the reduction of ideals for module, generalize the Aiken-Sataya theorem for ideals of module. We generalize the Aiken-Sataya theorem for ideal of 4 modules. And in Chapter 4, in Chapter 5, we explore the Sally modules and reduction of Sally modules and some results related to the reduction of Sally modules. Now let's begin with preliminaries. First, we define localization of ring and modules. To localize the module, we take
Hello, sir.
multiple. Hello.
Hello, Sharvan Kumar.
Yes, sir.
At first, explain your title of the thesis.
Sir, the title of the thesis is Study on Reduction, Multiplicity, and Ridge Algebra.
Explain what is the meaning of the reduction, what is the meaning of multiplicity, and then what is the meaning of Ridge algebra. Suppose you explain in such a way that suppose there is another man who is not the man of the algebra can understand about your title at first. Explain at first what is the meaning of reduction, what is the meaning of multiplicity, or one by one, what is the meaning of reduction in algebra?
Sir. Sir, we use reduction for if you study the larger structure of polynomial or difficult ideals, we apply reduction on ideas that is applicable for algebraic geometry.
Suppose algebra is given, and
Yes,
that is not so applicable, but after the reduction, it is more applicable.
yes, sir. Yes, sir. We can more applicable. We can easily applicable, sir. We can,
Explain these things by the help of one example. Presently, suppose if you have no
hello. Not audible, sir.
huh? Hello.
Yes, sir. Yes, sir.
Already you have written the reduction over multiplication model.
Yes, sir.
Just go to 3.3 or 4.3 and just explain 3.3.
3, sir.
3.3. 3.2 reduction over multiplication module. Just go to the just go to the slides and just say that's all.
Sir, slide is or not?
Hello. Suppose you are interested to say something about the preliminaries. Let him say something about our presentation at first. Are you interested to speak something more about the introduction?
No, sir. I can explain the chapters.
No.
Okay, go ahead.
Yes, sir.
Go ahead. Now you are interested to speak on which chapter?
Chapter 3, sir.
Chapter 3. Explain what do you mean by length of module? Give the example of a module and tell me what is the meaning of its length.
So length of module is defined as the composition series. It is the length of the composition series. We can explain with an example. Suppose Z12 is a Z mod Z12 is a module over Z. Actually, sir, it is a composition of composition of some module. It is a composition series and series of some module, which is each mi is some module, and mi modulo mi minus 1 is a quotient module. It's a simple module, sir. We give an example in Z modulo 12Z is a Z module, which is
Now at first present, give your presentations.
sir. I'm not completed, sir, length of the module, sir.
Are you interested to complete the length of the module?
Yes, so the module is contained in module generated by 2 and the module generated by 4 and the module generated by 6 is contained in 12. Sir, I can take board.
Present.
At first present your
Here,
length of a module will be always finite.
sir, length of the nodarian module is always finite.
If there is
Module
chance,
not necessary.
then length also may be 0.
No, sir, length never be 0.
Length is 0, then what can you say about?
0 is always contained in module itself. Then its length is 1.
And suppose length is infinity, then
Length is infinity. Then there is
Length-
infinite composition
if
series.
there is a chance that length of a module may be also plus infinity, no?
No,
Huh?
it's always less than, no? Strictly less than.
Greater than 0?
Always, always.
Hmm?
सर ये इसको प्रेजेंट करो.
Yes, hello.
Yes, sir.
Go to the chapter 3.
Yes, sir.
You are interested to say something about 3.
Yes, sir.
What do you mean by Hilbert polynomial? Hilbert polynomial. And the 28. Hello. By the help of your thesis, you can explain. Go on the page 28. 28 of your thesis. Hello.
Yes, sir.
Hello, Sharvan Kumar. Go to the page 28 of your thesis.
28.
28 of your thesis.
Yes, sir. When I see
Already you have given one example. Hilbert polynomial for a graded ring. Explain it. Page 28.
yes,
By the help of your thesis on the page 28, you can explain, because already you have given the example. Hello. This is the Kumar. Hello, Sharvan. Hello, Sharvan Kumar.
Yes, sir. Yes, sir.
Page
28. Yes, sir. Yes, sir. I have.
Then go to the page 28.
Yes, sir.
28. See here the example 2.10.8.
Yes, sir.
Explain Hilbert polynomial for a graded ring. Or at least you can read it. I will understand. इतना तो कर सकते हो.
Yes,
Read
sir. Yes,
it.
sir. It, sir, polynomial is mapping with mapping from polynomial to its length. Here in example 2.8, we take m is equal to r module itself. Sorry, r is equal to kx is a polynomial of two variables, and Hilbert polynomial is defined as is n plus 1 chosen 1, which is equal to n plus 1.
Chapter 3.
Yes, sir.
Chapter 3. Properties of reduction of modules.
Just the properties of reduction of module.
At first you speak, present your thesis. There's no time.
Sir, may I present chapter 3?
Yes.
Yes, yes.
Hello, sir.
Present yourself.
Present chapter 3. Hello, Sharvan Kumar.
Sir, am I audible, sir?
Yes. Okay, present chapter 3.
Chapter 3 है present.
अरे present chapter 3.
Okay, sir. Okay, sir. In chapter 3, we define the product of submodule of multi-module and also define the reduction of submodule of multiplication module and give some result related to the reduction of module. First, we begin with what is multiplication module. A module is multiplication if every ideal, if every submodule of n is of the form n is equal to im, where I is an ideal of R. And reduction of module is defined as the product of two modules is defined as n into n is equal to n colon m into k colon m into m. And a submodule k is said to be reduction of n if k is contained in n and there exists an positive integer such that this equality is hold. The least positive integer s for which is called the reduction number of the submodule. Reduction module with respect to k order. And we begin with the remark: if m is a multiplication module, then for every submodule of n, then n is of form n is equal to n colon m into m. And second remark is homomorphic image of multiplication module is multiplication module. And if n is equal to im and k is equal to jm are the submodule of m, then their product is defined as nk is equal to ijm. This last one. Here is the example. We take n is equal to 2z and k is equal to 3z are the submodule of z. Then their product is defined as 2z into 3z is equal to nothing but 6z. And another example is every cyclic R module is multiplication module, but the converse is not true. If you take reading R is equal to polynomial variable and m is equal to r or polynomial to variable, and if n is equal to and a submodule generated by x square or y square and another submodule generated by x square y and y square, then the reduction of then n is the reduction of k and reduction number is 2. Here is the lemma. If m is a multiplication R module, then for each ideal I of R, I commute with the product of submodules as well as I associate with their product, and the localization of multiplication module is a multiplication module. Last lemma is. Here is the theorem. If K is a of n, here K and n are the submodule of M. Then their localization is also a reduction of n. Here localization of n. If K is a reduction of W inverse n, and we multiply by W inverse I, then W inverse I into W inverse K is also a reduction of inverse I and W inverse n. And third result is, if W inverse I is a reduction of W inverse J, then W inverse I into W inverse n is a reduction of W inverse J into W inverse n for each ideal I and if, and the fourth result is, if W inverse reduction of W inverse J and W inverse K is a reduction of W inverse n for every I ideal contained in J and module K contained in n, then W inverse I into W inverse K is a reduction of W inverse J into W inverse n. And fifth result is, if W inverse K is contained in W inverse n and W inverse K colon W inverse M is a n colon W inverse n, and then W inverse K is a reduction of W inverse n. And the last, if W inverse M is finitely generated and W inverse K is a reduction of W inverse n, then W inverse K colon W inverse M is a reduction of W inverse n colon W inverse M. Here is the proof of the theorem. First proof.
There is no need to give the proof of the theorem. Hello?
Yes, sir.
There is no need to read out the proof of the theorem.
Okay, sir. Thank you, sir.
Hello, Sharvan Kumar.
Yes, sir.
Here in the page 37.
Page 37.
Example 3.2.3. Hello?
Yes, sir.
Example 3.2.3, you have written n is equal to 2z. Z plus z will be 2z or not?
Example 3.2.3. Yes, sir.
You have written n is equal to 2z. There is one minor query.
Yes, sir.
Z means set of integer.
No, sir. N is equal to z is a yes, sir. Is a set of even integer, but it is a module of z over z.
No. My question is z means z as set of integer.
Yes, sir. Z is a set of integers.
Just listen to z plus z will be 2z or not? A very simple question is z plus z is equal to 2z or not? Simply z plus z plus z is equal to 3z or not? Because you should know this is a very elementary question.
No, sir. Z plus z is not equal to 2z, or z plus z is not equal to 3z.
No. Why?
Because if we take z plus z, then
Z with addition is group.
suppose z.
No, z plus addition is group or not?
What, sir?
Z set of integer with addition.
Yes, sir. Z is a set of integer with addition.
With addition, this is a group or not?
Yes, sir. It is a group. It is also a abelian group.
Abelian group. Yes, this is correct. But my simple question, you are saying that z plus z is not equal to z. Then I am saying that how can you justify your answer? Can we z plus z will be what?
Yeah. So Z plus Z is Z because it's a binary operation. Every element of Z is in Z.
Is correct. Therefore, what will be 2Z?
2Z is 2 into Z, sir.
2 into Z means 2 twice Z will be that.
Then we required another operation, and then we have to move in ring.
Arrange. No? What will be 2Z?
2Z. So 2Z of even integer.
All the integer multiple up to the even integer.
Yes, sir.
Therefore, even integer will be not equal to the whole integer.
No, sir. Even integer not equal to the full integer.
Due to this reason, Z plus Z is not equal to 2.
Yes.
Are you understanding my point? Z plus Z will be Z. But twice Z will be set of integer, set of even integer.
Twice Z is a set of even.
Therefore, due to this reason, set of even integer is not equal to integers. So Z plus Z is not equal to 2Z. Hello?
Yes, sir.
Are you understanding my clarification?
Yes,
Z
sir.
plus Z is not equal to 3Z.
Yes, sir. Similarly.
There is no need to read out the proof of the theorem.
Just go
No.
on 3. Chapter 4.
What is the applications of the chapter 3? What are the applications of the chapter 3?
What are the application of chapter
3.
3? Sir, we have not investigated any applications, but we extend the results for
You should at least say something. What is the application of the chapter 3 in other branches of the mathematics, science, engineering? You have not investigated, but suppose question is coming at random, asked by any expert. Therefore, you should at least at this point you should think about this.
not audible, sir.
Then you can go to the chapter 4. Are you interested to say something more? Yes. What is the conclusion of the chapter 3? Hello?
Sir, yeah.
What is the conclusion of the chapter 3?
Conclusion is, sir, homomorphic image of and multiplication submodule is, sorry, sir, I go to the theorem. We have to go from last. We have to go to the last.
Hello, there is one very simple question. Multiplication of 2 modules will be always a module?
Multiplication of 2 module
Will be always a module?
will be algebra.
Multiplication of 2 modules is always a module?
Yes, sir. Multiplication of 2 module is not always, but if the module is faithful, then the multiplication. In every case, sir, multiplication of 2 module is multiplication module.
Suppose there are 2 modules, if they are satisfying some conditions, therefore multiplication module will also satisfy all the conditions which is satisfied by the individual modules. But I think multiplication of 2 modules will be not necessarily always a module. Hello. Multiplication of module will be performed under certain conditions. Always multiplication of any 2 module will be, as I know, this is not always a module.
If
Multiplication of a module by some module may be module. about this. Hello.
Yes,
At
sir.
least if suppose just in my suggestions, you can note the suggestion. If the multiplication of two module is always a module, then there should be general proof. If multiplication of two module is not necessarily a module, then there should be at least one example. Hello.
Sir, yes, sir.
As I mentioned, multiplication of two module will be not a module. At the time of the Viva-Voce examination, you should not give the such types of answer. Or I do not expect such types of the
Example 3.2.3. Here and
For commutative ring, it's always commutative ring, it's always
multiplication module.
दे रहा है
मैं शुरू में बोल दिया in the beginning you have mentioned that multiplication of two module is always a module. This is not the correct answer. Correct answer now you are giving the example that the example 3.3. It means multiplication of module will be a module under the conditions. Commutatively.
Fourth chapter present.
Hello.
Yes, sir.
Therefore, already you have given that multiplication of two module will be a module under the conditions. Condition is already mentioned. In general, this is not true. Hello?
Yes, sir.
Yes. Come to the chapter 4.
Yes, sir.
Multiplication of modules in Rig algebra. I first explain the Rig algebra. At first algebra, then Rig algebra. Explain what do you mean by algebra?
Sir, it is algebra of an ideal is the direct sum of the grading of the ideal, and the D algebra of ideal for module is the direct sum of the I to the power n m.
What do you mean by ring offsets? No.
Yes, sir.
What do you mean by ring offsets?
What is
Ring offsets.
ring, not theory?
No, ring offsets.
Ring.
Offsets.
Yes, sir.
What do you mean by ring offsets?
Ready now?
Just
आवाज
hello.
Yes, sir.
Yes, just I am going to give you the hint. Suppose yes, hello.
Yes, sir.
Hello. Suppose yes being non-integer.
Yes, sir.
No. Suppose X be a non-integer. Yes be a collection of subsets of X. Therefore, yes is said to be a ring of sets. If yes is closed under symmetric difference A, B belongs to yes implies B means A minus B union B minus A. And if B belongs to yes, therefore A intersection B also belongs to yes. Therefore, this is the ring of subsets of yes. Therefore, tell me. Hello. Are you listening?
It is also complete language. 9 zeros.
Hello, Sharvan Kumar.
Hello.
Hello.
Yes, sir.
I have already given the definition of ring of sets. X be a non-empty set. S be a collection
Sir.
of subsets of X. Hello. मुझे कुछ प्रॉब्लम हो
The title of the chapter 4 is multiplication of module in this algebra. In this chapter, we investigate the properties of reduction of ideal for module and extend the and give the result of Akin-Sataya theorem for ideal for module. Before we go to the theorem, first we define the Ries algebra and fiber cone. Ries algebra of an ideal for module is defined as the direct sum of the grading rate I to the power m. And if Rm is Noetherian link, the fiber cone is defined as the quotients of the Ries algebra of m. And it is the direct sum of I n to the power m quotient m into I n m. The dimension of the fiber cone of ideal for m is called the analytical spread of I for m, and it is denoted by lambda I m. And reduction number is if I is said to be reduction of j for m, if I j to the power n m is equal to j to the power n plus n m, for some n is greater than equal to 0. And the reduction number of j for m is the minimum of n such that reduction holds. And minimum n such that reduction hold is called the minimal. If I is the minimal reduction of j. If I is a reduction I of j is called minimal reduction of j for m if no strictly contain in I a reduction of j for m. For every ideal I contained in j is a reduction of j for m such that analytical spread of j for m is less than the minimal generating set of the ideal I. If the residue field is infinity, the dimension of fiber cone is equal to the minimal is the number of minimal genetic set of the ideal I. Here is a preposition for a finitely generated R module. I is contained in J ideal for the of an Noetherian R. Then I is a reduction of J in R value initial of M if and only I is a reduction of J for M. And here is the proof. And what is nilpotent ideal? Ideal J is set to nilpotent ideal for M if j to the power n is contained in a letter of m for some n is greater than 0. And reduction ideal is defined as If an ideal J is important ideal, then any ideal contained in J is called a reduction of J for M. And next, here is a proposition. Let Rm be a local Lorentzian ring and J be a M priority ideal of R. Suppose M is a finitely generated R module, then dimension of M is equal to 0 if and only if J is an important for M. This is the proof. And here is another lemma. If an ideal J is contained and in J and M is finitely generated, then I plus Mj is a reduction of J for M if and only if I is a reduction of J for M. And this proof, the proof of the lemma is by using this Nakama lemma. Then we can prove this lemma. Here is a proposition. If Rm is a local Noetherian ring, J in ideal of R and M is a finitely generated module. Suppose Ui minus Vi belongs to Mj, then ideal generated by U1 UR is a reduction of J for M if and only if ideal generated by V1 VR is a reduction of J for M. This result is proved by using above lemma. And the next proposition is if ideal generated by XR element is a reduction of J for M if and only dimension of this quotient ring is 0. Here is the proof of the proposition. And this is a theorem. A module is finitely generated and ring is Noetherian local ring and the infinite residue field is K and ideal generated by n element is contained in J, then there exists a non-empty open subset of K to the power Sn where then the state is of the form.
Hello.
Yes, sir.
What is the importance of reduction of modules? By reduction of the modules, which property you are deriving and which property you are obtaining that is not obtained by the help of the reduction of the modules. I am asking very easy question and I am also helping you. I am sitting here to approve your Viva-Voce. Keeping all these things in your mind, you should give some answer as some questions.
Sir, this result is already proved for reduction of ideals, and we expect this result for reduction of ideal for module. And
Which theorem?
this result is this theorem.
Page number?
Slide 46.
Huh?
In slide 47.
47.
Page 47?
Oh, sir.
Page 47, which proposition? 4.4.
The theorem 4.3.4. Hello. Hello.
ये तो रिटायर्ड है
Sir, mic is muted. वो रुकने बोले Yes. This term is and here is the Akan-Sathaya theorem. If the ideal z to power n can be generated by and by generated by fewer than n plus s chosen s elements, then there exists x1 x in z such that x1 ideal generated by s elements into z to power n plus 1 is equal to z to power n and we extend this result for reduction of ideal for module, and we choose the minimal generating element of the ideal for module is less than n plus 1 s chosen s, then the reduction holds for ideal for module, and this proof is based on the double induction of n and s. And in chapter 4, the title of the chapter 4 is Coefficient of Hilbert Polynomials and Sally Modules. This chapter examines the Sally module, Ries algebra, fiber 4 and symbolic Ries algebra for the Noetherian local link with infinite residue field. In this chapter, we extend the result from the symbolic Ries algebra of ideals to the modules and establishing condition for Noetherian property of symbolic Ries algebra of modules. Here R is Noetherian ring and S be the total ring of coefficients, where W is R minus S or where S is the set of all non-zero divisor of R. And we define the symmetric algebra by this. And here we define Ree's algebra by the quotient of symmetric algebras. And fiber cone is defined as the direct sum of the quotient of graded module, and its dimension is called the analytical spread of M, and it is denoted by LM. Here is an example, and this is another example. This is the example where Ree's algebra of M is the symmetric algebra of M, and symmetric algebra, and this example shows that Ree's algebra of M is Noetherian. The Ree's algebra of Noetherian module is non-Noetherian, and reduction of module is defined as if M is integral over N, if M to the power N plus 1 is equal to Nm and N into M to the power N. Multiplication is taken as the graded ring for some N is greater than 0. The list number N is called the reduction of M and is denoted by R, and the submodule N of M is said to be the minimal reduction of M if it is not contain any submodule satisfying the reduction properties. And the definition of ideal module and equi-multiple module. And here is the example, and this is an important lemma. Rank of M is the minimal genetic set of M if and only if M is free R module. And here is the proof. And this is another proposition. Any finitely generated module M over eta with minimal genetic set of M is equal to the analytical spread of M as a minimal reduction. And this is the proof of the proposition. And if M is a free R module with rank E, then M has no proper reduction. And this is the yes sir.
Hello, Sharvan Kumar. Give one example of a Sally module. Hello. Give one example of a Sally module.
Yes. Sorry sir, I don't follow it right now. Here is another proposition. Any reduction N of M has rank, and rank of N is equal to
Hello.
rank of.
Hello, Sharvan Kumar.
Yes, sir.
Give the example
Yes,
of the Sally module. Example of the Sally module.
हम लोग बैठे हुए हैं ना, बहुत सारे इन लोग पुराने टीचर्स को बुलाते हैं हर एक तो एसपी राय, बीजी प्रसाद, पीसी सिन्हा सब बैठे हुए हैं वहाँ। पूरा एक तरह से डिपार्टमेंट मिलता है।
with minimal genetic set of M is equal to the genetic spread of M has a minimal reduction. And this is, here is the proof of the proposition. If M is finitely generated 3R module with rank E, then M has no proper reduction. And any reduction N of M has rank, and the rank of N is equal to M. Here is the definition.
सुनाई दे रहा है ना सर?
Hello, Sharvan Kumar. Sharvan Kumar.
Yes, sir.
The definition of the Sally module already you have given on the page 63. Read the page 63.
Page number 63, sir.
At least you can read. I am asking the definition of the Sally module. Therefore, you have already defined Sally module on the page 63 of the thesis. Page 63 of the thesis.
Yes, sir.
So at first read it.
Sally module is an
Suppose N is a subset.
Sir, not audible, sir.
Huh?
Not audible.
Come to the page 63 of your thesis.
Yes, sir.
Page 63.
Yes, sir.
Sally
The Sally
module.
module,
Read it.
the Sally module of M with respect to N, where N is the submodule of M, is defined as the direct sum of the quotients of graded module of Mn upon M into Nm. M into N to the power N. Yes, sir. Mn is the graded module, sir. And Sally module is defined as the direct sum of the quotients of the graded module.
Can you give one example of a Sally module?
Oh, sir, I not recall like that.
Huh? Hello. Have
Yes,
you
sir.
any example of the Sally module?
No, sir.
किसी का क्या होगा?
I use reduction on Sally module.
Hmm?
Right.
But already you have given the example on the page 65. Read it. Page 65.
Yes, sir.
Page 65. Example 5.3.3. Read it.
If we take that is a P module, and that is a where F is generated by x1 x is such that x1 x2 plus x is equal to 0 is a submodule of M dash of dimension e minus 1. Mapping defined from is a symmetric algebra of M dash. And symmetric algebra of M is the direct sum tensor algebra of M, where tensor algebra is defined as the sum of the graded of M to the power. Algebra of M is K plus E minus chosen E 2 of dk. Yes. Now we proceed to the next proposition. The Sally module of Rm is equal to 0 if and only reduction of n is equal to 1. Now we define the Ries algebra of ideal.
आपको चाहिए?
And the defined symbolic Ries algebra of a module.
ले लीजिए आप. सबमिट कर दीजिए. अरे
Here is a
लिखिए
preposition.
क्या आप रखिए, क्या दिक्कत है? कोई दिक्कत नहीं, रखेंगे।
If M is the
ठीक है, हम सब पेपर
penalty
देखें पूरा
generated
ये।
social media
ये सब
module
भी
having
बहुत अच्छा
rank
था।
and is a flat
ये
R
वाला
module
क्वेश्चन
then
अच्छा ये आप किए थे, दिखाइए तो।
accommodated A algebra
चलो चलो।
R M tensor A isomorphic to
X2 is equal
this
to
algebra
X1
form tensor
बनेगा।
A and here is the proof.
इसका आंसर यही होना चाहिए। मतलब एक एग्जांपल दे रहा नहीं।
This is a corollary. Yes.
मतलब कोई भी कंटिन्यूअस
And
बाइजेक्टिव
here is a
फंक्शन
theorem.
बाइजेक्टिव
If
फंक्शन होगा तो क्लोज हो
dimension of
जाएगा।
R is G and isomorphic to
Result
the
है ना
free
सर पूरा।
R module with rank is greater than 0 that is contained in
बाइजेक्टिव फंक्शन
M dash of R module and then symbolic region algebra
सही
is
समझ
Nodarian ring, then there exists space greater than 0 such that length of hypercone of this symbolic region algebra symbolic this module M is less than G plus 1 E minus 2.
हाँ, इसको रिजल्ट को बढ़ाते रहिए, आगे बढ़ाते रहिए।
जितना नया वाला आया है वो सब उसने टेढ़िया है।
And this is the last proposition of this chapter. M is contained in M dash is isomorphic to its free module is an ideal module which is greater than 0. Then this algebra of M be a Nodarian ring with graded symbolic M percent M greater than 2. Then depth of this is height of fitting ideal of many and
रखेंगे
then
सब तो घटा हो जाएगा। कौन घटा हो जाएगा, कौन फायदा हमें दे सकते हैं, कौन किसको क्या फायदा दे सकते
अभी भी घाटा नाफा चल रहा है। अभी भी घाटा नाफा चल रहा है।
नहीं सुनाई दे रहा
फिर से
हेलो श्रवण कुमार, पब्लिकेशन में जो है हेलो श्रवण कुमार, हेलो श्रवण कुमार, नहीं सुनाई दे रहा। श्रवण कुमार,
yes sir.
हेलो, come to the your published paper.
Yes,
फर्स्ट
sir.
पेपर इज इफेक्ट ऑफ मास
Yes.
ट्रांसफर, इसका दूसरा है क्या? हेलो, इफेक्ट ऑफ मास
Yes, sir.
ट्रांसफर विथ बाउंड्री लेयर फ्लो अलोंग वर्टिकल thin needle. This is your publication?
No.
No, sir.
Hello?
No, sir. No,
No,
sir.
sir, this is not my
No, sir.
publication.
None
हाँ?
of the paper is in.
नहीं
None of the
ये
paper.
नहीं है, इधर है इसमें, ये वाला।
Some results and reduction of ideals with respect to modules. This is your publication? Hello,
Hello.
Sharvan Kumar.
Yes, sir.
अरे, just come to the abstract. IDNCMAS oblique MT07. Some results and reduction of ideals with respect to modules. Today already you have included the first
ये ऑन एप्लीकेशन यहाँ दे दी। ये वाला
some results and reduction.
अगला मिलेगा।
अरे, one page of the paper is already included in your thesis.
Yes, sir. Yes,
Hello?
sir. All of the chapter are included in my thesis, sir.
Just listen my point. Just, there is one query. You have written one paper. Your paper has been published.
In conference.
In conference, sir.
Conference.
Yes, sir. Yes, sir.
अच्छा, this is in the conference. Come to the just. ये क्या conference है? Just wait.
ये
एक reduction आप
ये पेपर उसको थीसिस में उलटने का पेपर जहाँ पे लगाया।
हेलो,
Yes, sir.
reduction of multiplication of modules and its properties. खुद ही publish है ये क्या?
हाँ, publish है।
Yes, sir. This paper is also published in the conference proceedings, sir. Published by the Grutter.
And come to the next, reduction of ideals for module.
ये है।
Volume, this is volume 12. 12.
ये है।
Special issue.
Palestine.
Palestine Journal
Journal of Mathematics.
Technique.
नहीं, Palestine Journal of Mathematics.
अच्छा, Palestine Journal of Mathematics. This is related to which chapter?
Sir, this chapter is related to fourth, sir.
No, this publication.
Fifth chapter, sir.
Fifth chapter. Hello, this
Yes,
paper
sir.
this chapter is related to fifth chapter. No.
Third chapter.
Just
Sir, second publication, symbolic real algebra. Sir, second publication is related to fifth chapter, symbolic real algebra and reduction of module.
अरे भाई, just listen my question. Give the answer of your question. Answer related to my questions. Just here your Palestine Journal of Mathematics. Your paper has been published. Production of ideals for modules with Priti Singh. Hello. My
Yes, sir.
question is, this publication is related to which chapter of your thesis?
Second chapter, sir. Fourth chapter.
Second
Reduction,
publication
नहीं।
related to fifth chapter.
अरे, just the reprint which is attached with the thesis, I am asking related to that question. Reduction of ideals for modules. Palestine Journal of Mathematics.
Yes, sir.
ये कौन है? देखियो।
पहला
related to
which chapter?
which chapter?
Fourth chapter, sir.
Fourth chapter is multiplication of modules in real algebra. You have written.
Third chapter.
Sir, we use multiplicity as also in this paper.
अरे भाई, no, you are saying that this is related to the fourth chapter, but fourth chapter is multiplication of modules in real algebra.
Yes, sir.
To that This should be related to the third chapter.
Third chapter is related to fourth publication, sir, which is published in the proceeding of.
भाई क्या कह रहे हो भाई? क्वेश्चन समझो पहले. तुम लिख रहे हो कि reduction of ideals for modules. You are saying that this is related to the fourth chapter. Fourth chapter is the multiplication of modules, multiplicity of the modules. Perhaps this should be related to the second properties of reduction of the modules. This should be related to the third chapter.
Yes, sir.
Huh?
Yes, sir.
नहीं सही कह रहा है, ये वाला कह रहा है.
हाँ?
ये रिडक्शन फॉर मॉड्यूल्स है ना ओवर आइडियल्स के लिए, ये सही है. हाँ, ओके वी गॉट इट. फोर्थ चैप्टर 4.3 जो है ना, यही है, सेम है.
It is related to the fourth chapter.
Chapter.
It should be clear from your side. This is related to the second chapter or third chapter or fourth chapter.
नहीं तो इन लोग ऐसा नहीं करते. जैसे वो पेपर छापा, उसका जो एक्सटेंशन वर्जन है उसको थीसिस में यूज करेंगे या एक पार्ट यूज कर सकते हैं. इन जनरल ऐसे ही होता है. ठीक है. और
सेकंड चैप्टर
Second chapter is preliminaries.
algebraic structure,
their application.
algebraic structure and their application.
ये है preliminary.
एक मिनट just wait.
क्या नाम है?
Algebraic.
Symbolic algebra and reduction. ये लिखा है, ये symbolic algebra and reduction analysis.
This is related to which chapter? Hello. This publication is related to which chapter? Second publication. Second chapter. And second publication. Let's conclude the
Preliminary बोल रहा है.
क्या बोल? Second publication is related to which chapter?
Second publication related to fifth chapter.
Fifth chapter.
Fifth chapter. And
Yes, sir.
third.
What, sir?
Third publication.
Third.
Reduction and the Sally modules.
Sir, this also second and third publication is related to fifth chapter. Fourth one is related to second chapter.
Which publication is best in your opinion?
Of my publication, sir.
Third publication. Which publication is best in your opinion?
Sir, second publication, sir. Algebraic is second. First and second are good, sir.
Is any one of these publications related to ACI journal?
What, sir?
Is any one publication is related to ACI? ACI
Not
and
audible, sir.
ACI? Huh? Hello.
Yes, sir.
Your paper has been published in the so many journals, 4 journals, different journals. My question is, any one of these journal is ACI?
No, sir. Scopus, sir. First and second are Scopus.
And which chapter is the best chapter in your opinion?
Sir, chapter 4, sir. Chapter 4 is best. We can not say. Chapter 4
and the last question is, what is the scope of future research in your idea?
Sir, we can define the fiber cone and Rees algebra for the multiplication module. and we can extend our result towards multiplication module.
You are net Pyara?
What, sir?
Hello. Hello, Sharvan Kumar, you are net Pyara?
Yes, sir.
You have completed Ph.D. in how many years?
Not audible, sir.
How much time you have taken to complete Ph.D. degree, Ph.D. thesis under
Sir,
the supervision
Fourth
of Dr. Priti Singh?
year, sir.
Huh?
Fourth year.
Fourth year.
Yes,
So
sir.
let us conclude. Hello,
What, sir?
Professor. Let us conclude. Professor S.B. Rai, Priti Singh, and other senior professors of the University of Patna. Hello, I have
Yes,
due
sir.
regard and respect to the University of Patna because there was very renowned Professor K.K. Jha in the Patna University. Hello.
Yes, sir.
Just I am going to mention one thing. Have due regard and respect to the University of Patna, the Department of Mathematics of the Patna University. During 1985, there was a very senior professor, Professor K.K. Jha. He was the head of the department of the Patna University. He was also the principal of the Science College, Patna. He selected me as a teacher in the Central University in 1985. There were so many applicants, but he asked several questions to me. But at that time, just I had completed my PhD. I answered all the questions, but there many people in the opinion that so many senior faculty members who had the interview, but at the blessing of the Professor K. I got their selections. I want to mention here that Dr. Priti Singh is already my student. I have taught him in the MSc of this Banaras University, Hindu University. When I was the head of the department, there was also the selection committee was under, when I was also a member, but at that time I was very hopeful that she will get the selection, but the situation was the different. She is good researcher in my opinion. I have already seen her, the thesis guided by her. I have also assessed her performance during as a selection committee. So not only we can say that she is good in the teaching, knowledge and the research, but she is excellent in the teaching, research and the guidance of the research scholar. Already when this thesis came to me, this is the just here our field of specialization is the analysis. Analysis covers already algebra, topology, and all other. That at the time of accepting this as an examiner of this thesis, I was hesitating. But when I read one by each and every line of this thesis, therefore this thesis not reflect only the ability of the students. This also reflect the capability and the good, excellent guidance of the supervisor. Therefore, I am fully satisfied from my side to recommend for award of the Ph.D. degree to Mr. Sharvan Kumar under the supervision of Priti Singh. And just one point is written from my mind. If from the expert side, if there is any question from the expert side, any question from the audience side, because there are so many senior professors who are contemporary to me, and some are senior to me, and some are going. I am going to retire on the 30th June, and some of them will also retire in 1 or 2 years. Therefore, if any one of you have any questions or any query or any clarification by the side of the student, Mr. Sharvan Kumar, then any one of you can ask the question. Otherwise, if there is no any clarification from the senior faculty members of the Department of Mathematics of the Patna University, so let us to the conversation of only 15 seconds with the head of the department. Hello, Professor S.B. Rai Sahab. Hello. Hello, Professor S.B. Rai Sahab.
He's coming.
Hello, sir.
Hello, sir.
Hello, sir. Have you any question from the student side, or have you any questions?
Student want to ask any question? Hello.
Or any teacher can ask any question, any faculty member can ask any question.
Hello, sir. He is coming, sir. आइए
तो रिसर्च स्कॉलर से पूछेंगे।
आइए अविनाश जी आइए। अरे आप रहा का
So I would like to ask a question that can you give an example of Gauss algebra, right? And explain the depth and height of that model involved.
करेंगे। किसी का कोई क्वेश्चन है? अगर नहीं है तो डायरेक्टली कॉन्ग्रेचुलेशन करें।
If we explain the height of an ideal module,
ठीक है।
length of the longest chain of primary.
उन लोग आपस में पूछ रहे हैं।
R is a polynomial ring and polynomial of one variable. That is denoted by a single element. Then the height is the height. Ideal prime ideal is generated by single ideal generated by single element is PID. Then it also prime, and the ideal generated by single element is contained in the main polynomial of single variable. Then we can find a single chain. Single chain.
Yes, sir. नहीं, इसमें ऐसे भरना है, लिखकर अपना जो रिकमेंडेशन है।
Your research in real life.
Hello.
पता नहीं apply algebraic symmetry. They also use computer is nothing but tools of algebraic symmetry.
Hello. Hello.
Yes, sir.
So I congratulate to the candidates, Mr. Sharvan Kumar, for successful completion of the Viva-Voce examination. He will get the Ph.D. degree after completing some formality of your university. I also congratulate Dr. Priti Singh for successful guidance of these candidates. Thank you very much.
Thank you, sir. Thank you, sir, for giving me the valuable time. Thank you, sir. And thank you to all the participants, teachers, professors, come to the department and give the valuable time and some characteristics the thesis and discussions, all these things. Thank you very much.
Thank you very much. Hello, Priti Singh.
Yes, sir.
I will write the report, then I will send you. You can submit to the university.
Yes, sir. Report, I will send you email, sir.
Okay, thank you very much.
Thank you, sir.
Now Viva-Voce examination is over. Thank you very much. अगर हमारा खोल दीजिए तो देख सकते हैं।
चढ़ाएंगे आप?
नहीं बचिया
चढ़ाएंगे तो आप उसी का लैपटॉप लाएंगे?
ऑन करके बोलिए बेटा।